I'm Tuba Göksel.
I'm Gaurav Mittal.
Today we're here to talk about our low-power Pmics. Our low-IQ Pmics are an innovative approach from Mobile Power Business Unit. And low-power Pmics target platforms that are highly constrained on solution size and power consumption, but yet still require high flexibility and high functionality. When I say highly constrained, visualize your ear canal or lifestyle solutions that require applications that need to be sleek and fashionable. Our Simo portfolio has ICs that are a perfect solution for emerging low-power applications, including wearables, hearables, connected sensor node, connected living, smart cities, smart homes, virtual reality, and gaming. All of these applications require battery lifetime, efficiency, and small solution size, as the user does not have the frequent downtime to charge the device. The small size mandates that the device cannot get too hot, as these devices might be getting in touch with your sensitive skin. You might be putting them in your ears or wearing them over your eyes, or you might even be putting them on your baby. As a new mom, I'm a huge fan of the Smart Sock, which monitors my baby's heart rate and oxygen level. From my phone, I'm able to get the data and the signal from the device, and I'm not even sleeping in the same room with him. So you can imagine how good the quality of my sleep is. So here I brought a picture of my baby wearing the Smart Sock. So Gaurav, can you talk to us about some of the system requirements for designing such low power solutions?
Sure, thanks, Tuba. The most common requirements for a low power system is that you need a lithium-ion battery charger for making it a portable solution. You need 1.2 volt rail for a microcontroller, a 1.8 for a Bluetooth. You need about 3 to 5 volts for sensors and NFC kind of applications. So all of this are very typical for these kind of systems. And our Pmic, which is a Simo Pmic, helps to cater all of these in one solution. And the whole aim is that we want to reduce the pain points for the system designer. Because what we want is that they can get all these resources with one stop solution, and they can control all of them seamlessly. Right? So that's what our Simo Pmic does.
So can you talk about how Simo works?
Sure. So Simo, the single inductor multiple output. So let me show you. So we have a single inductor, multiple outputs, and anytime any one of the output goes hits a certain threshold, it tells the controller that it has to be serviced. What that means is that the controller then controls the FETs. They initiate an energized cycle, which is an inductor charge cycle, which builds up energy in the inductor, followed by a discharge cycle, which transfers this energy into a capacitor. So this would happen for the output 0, the output 1, and then the output 2. Right? And this doesn't have to be sequential. It can be in any order which the regulator says that I need to be serviced. So this is a very flexible and very adaptive kind of a solution and helps cater to this whole solution. One key thing I want to bring up is that all of this is done with one inductor. A traditional solution might require 3 inductors, which is again more cost, more space. So that's why it's so innovative.
So can you talk about why Simo from Maxim?
Sure. So keeping in mind of all these system needs, we have very carefully chosen the features which have to be integrated. Like the battery charger, we have the 3 output Simo buck boost, so which means from 0.8 volts to 5 volts, it's just one inductor, one regulator. We have an LDO integrated. The LDO helps in reducing noise for rails which are very noise sensitive. So that is already integrated. We have LEDs for indication. It has an on-off controller to control the whole sequencing with a push button. And then the whole solution size is about 19.2 millimeters square, which includes the inductor, which includes the output capacitor and the IC. So very compact, right? And the supply current is about 5 microamps, which includes when all 4 regulators are regulating, which is 3-channel Simo and an LDO, which overall with this we get very good, high system efficiency. Because you never use just one regulator, you use a combination of LDOs and other things together. So this overall provides excellent system efficiency. So that's why Max7.
Great. So our goal for the designers out there is to get you to design platforms as efficiently and quickly as possible. Sure. So how easy is it to design a platform like this?
Sure. So let's look at this. What I'm showing here is a prototype board. It's a Max32620 feather board. What it has is it has a Max7 microcontroller. It has over here, what I'm showing is the Simo Pmic with 1 inductor. So you see it's a very, very compact solution size. We have the Max77650 fuel gauge. And this overall board, you can attach, additional number of sensors like a temp sensor, proximity sensors. You can attach the USB. You can have the battery connected. So a very flexible protocol, board which we have here. And we actually made a demo out of this. So I'm going to show you that. In that demo, we're actually powering the proximity sensor. We are powering the microcontroller. We're powering the display. But you can also power the headphone, the Wi-Fi, and even the Bluetooth, which shows that it can be made as a whole complete wearable solution. Right. So let's look at a demo. So here's a demo. This uses the proximity sensor, and the Simo IC is the Max77650. If you can put your hand over the proximity sensor, you see that this triggers an event which shows that we're using the Simo Pmic, and it also shows what Vout rails this Pmic has been programmed for. So it's showing you about 1.2 all the way to 3.3. Right. Now if you shine light on the sensor, you'll be able to see the battery health. In this case, you see that the battery voltage is about 4 volts, and the time to empty is about 13 hours. It also shows about how much supply current is being consumed. So all of this information is very valuable, and it shows how easy it is to go from a prototype board to have something which which works, which responds to the sensors, and makes it very, very relatable and very easy to design.
Yeah, it sounds like these would be a perfect solution for wearables.
Sure. Great.
Well, thanks so much for watching us. And for more information about this exciting, innovative technology, please visit us at maximinintegrated.com/Simo.
Thank you.